Right now, you are looking at a screen. You can see colors, shapes, light, movement. Perhaps you can hear a voice. Everything feels completely real. But there is something strange about what you are experiencing. You have never actually seen reality itself. You have only experienced your brain's interpretation of it. Think about that. Your eyes do not send photographs into your mind. They detect light. Photons enter your eyes and strike specialized cells inside your retinas. Those cells convert light into electrical signals. The signals travel through your nervous system into your brain, and somewhere inside, billions of neurons begin working together. Edges are detected. Movement is calculated. Depth is estimated. Objects are recognized. Colors appear. And finally, a world emerges. The world you experience as reality. But that world exists inside your perception. Consider color. A red apple seems obviously red. But redness is not simply sitting on the apple, waiting to be collected by your eyes. The apple reflects certain wavelengths of light. Your visual system processes that information and produces the experience we call red. Another creature with a different visual system could experience that same object very differently. Some animals detect ultraviolet light that humans cannot see. Others sense infrared radiation or perceive polarized light. A bee, a snake, and a human can occupy the same physical environment, yet experience remarkably different sensory worlds. So which one sees reality? Perhaps none of us see all of it. Evolution did not necessarily design our senses to reveal every detail of the universe. It shaped organisms to detect information useful for survival. Food, danger, movement, faces, distance, opportunities. Your brain constantly filters an enormous amount of information. Most of it never reaches conscious awareness. And sometimes the brain goes even further. It fills in what isn't there. There is a small region in each of your eyes where the optic nerve leaves the retina. There are no light-sensitive cells there, a literal blind spot in your vision. Yet you don't walk around seeing a black hole floating in front of you. Your brain fills the missing information so seamlessly that you never notice. Optical illusions reveal just how powerful this process can be. Two identical colors can appear different because of their surroundings. A stationary image can appear to move. A flat surface can suddenly seem three-dimensional. The outside world hasn't changed. Your interpretation has. And vision is only the beginning. Your brain reconstructs sound, touch, balance, temperature, even your sense of where your own body is. The reality you experience is not a simple recording. It is a reconstruction, a model continuously generated from sensory information. And most of the time, that model works extraordinarily well. Well enough to build cities, cross oceans, land spacecraft on other worlds, and study galaxies billions of light years away. But this creates a profound philosophical problem. If everything you experience has already been processed, filtered, and reconstructed by your brain, then how can you know what reality looks like without you? Perhaps the world you experience is not reality itself. Perhaps it is an interface, a biological representation of something deeper. And if our ordinary perception already hides so much, things become even stranger when we look beneath everyday reality into the quantum world. Because there, even the universe itself stops behaving the way reality should. Remaining. For centuries, scientists believed reality worked like an enormous machine. Objects had definite positions. Events had clear causes. And if you knew enough, you could predict what would happen next. Then, physicists looked inside the atom, and reality began to fall apart. At the smallest scales, nature does not behave the way our everyday experience suggests it should. Particles, such as electrons, do not always behave like tiny solid objects. Under certain experimental conditions, they behave like particles. Under others, their behavior reveals wave-like properties. One of the most famous demonstrations is the double-slit experiment. Imagine firing particles toward a barrier containing two narrow openings. Behind the barrier is a detector. If these particles behaved like tiny bullets, you might expect two simple bands, one behind each opening. But instead, under the right conditions, an interference pattern emerges, a pattern associated with waves. Even when particles are sent one at a time, the pattern gradually appears. Each individual detection occurs at a specific location. Yet after many detections, the distribution reveals something profoundly strange. Quantum mechanics describes the possible outcomes using a mathematical object called the wave function. Before a measurement, the system can exist in a superposition of multiple possible outcomes. Then, when a measurement occurs, we observe one definite result. But what exactly counts as a measurement? And why do we experience one outcome rather than a combination of possibilities? This is known as the measurement problem. And after more than a century, physicists still disagree about what quantum mechanics is telling us about reality. There are multiple interpretations. The Copenhagen family of interpretations emphasizes the probabilities associated with measurement outcomes. The many worlds interpretation suggests something far more radical. Perhaps the wave function never collapses. Instead, different possible outcomes correspond to different branches of reality. Other interpretations attempt to explain quantum mechanics in completely different ways. And so far, there is no universally accepted answer to what the mathematics ultimately means. But there is another phenomenon that makes reality even stranger: quantum entanglement. Two particles can become correlated in ways that classical physics cannot fully reproduce. Measure certain properties of one particle, and the results are connected to measurements of the other, even when they are separated by enormous distances. Einstein famously criticized this kind of phenomenon as spooky action at a distance. Later experiments, including tests of Bell inequalities, showed that nature really does exhibit correlations that cannot be explained by simple local hidden variable theories. Yet entanglement does not allow us to send useful information faster than light. Relativity survives, but our intuitive picture of separate objects with completely independent properties becomes harder to maintain. And here we must be careful. Quantum mechanics does not demonstrate that human consciousness creates reality. In physics, an observation does not necessarily mean a conscious person looking at something. It refers to a physical interaction that produces a measurable result. Still, the mystery remains. Quantum mechanics is one of the most successful theories ever created. Its predictions have been tested with extraordinary precision. Modern electronics, lasers, and much of today's technology depend upon it. We know the equations work. What we still debate is what those equations tell us about the underlying nature of reality. Perhaps particles are not tiny objects in the way we imagine them. Perhaps probability is woven into nature itself. Perhaps reality contains structures that human intuition simply did not evolve to understand. And if our senses show us only a reconstruction, while quantum physics reveals a world completely unlike ordinary experience, another question becomes impossible to ignore. What if the reality we call fundamental isn't fundamental at all? What if everything, matter, space, time, even ourselves, emerges from something deeper? Information, mathematics, computation? And that leads to one of the strangest questions humanity has ever asked. What if our entire reality is a simulation? Imagine that tomorrow humanity creates a perfect simulation. Not a video game, not virtual reality, but an entire world. Mountains, oceans, cities, weather, history, life, and eventually, conscious beings. Beings capable of thinking, remembering, dreaming, loving. They look toward their simulated stars and ask the same question we are asking now. What is reality? From inside their universe, everything feels real. They can touch objects, measure distances, discover physical laws, build civilizations, study their cosmos. Perhaps they even create simulations of their own. But there is one thing they cannot easily see: the computer running their universe. Now ask yourself a disturbing question. How would they ever know? And more importantly, how would we? This idea is often called the simulation hypothesis. It became famous partly because of philosopher Nick Bostrom. In 2003, Bostrom proposed an argument about technologically advanced civilizations. Very roughly, if civilizations eventually become capable of creating enormous numbers of realistic simulations containing conscious beings, then simulated observers could potentially become far more numerous than observers living in an original biological reality. But this is not proof that we live in a simulation. It is a philosophical argument built upon assumptions we do not know are true. We do not know whether consciousness can be simulated. We do not know whether civilizations could ever possess enough computational power. We do not know whether advanced civilizations would even want to create such worlds. And most importantly, we currently have no confirmed evidence that our universe is simulated. Still, the idea forces us to confront something profound. How would we recognize fundamental reality if we encountered it? Perhaps we would search for glitches, patterns, limits, evidence of computation. Some have wondered whether the smallest scales of nature could resemble the resolution of a digital universe. Others have searched for unusual patterns in fundamental physics. So far, nothing has demonstrated that reality is running on a cosmic computer. But perhaps the deeper lesson is not about computers at all. Modern physics already tells us that reality is radically different from everyday appearances. A table feels solid. Yet at the atomic level, matter consists largely of structured quantum systems with electromagnetic interactions, preventing objects from simply passing through one another. Space feels empty, yet modern physics describes fields extending throughout the universe. Time feels universal. Einstein showed that it isn't. Color feels like a property of objects, yet color is an experience produced by biological perception responding to light. Again and again, the universe reminds us that appearance and underlying structure are not necessarily the same thing. Perhaps reality is made fundamentally of particles, perhaps fields, perhaps information, perhaps something we have not yet discovered, or perhaps asking what reality is made of is itself the wrong question. Human beings evolved on one small planet, around one ordinary star, inside one galaxy among countless others. Our brains were shaped to survive, not necessarily to intuitively understand the deepest architecture of existence. Yet somehow, those same brains learned to split atoms, detect gravitational waves, photograph black holes, explore quantum mechanics, and reconstruct the history of the universe. Perhaps we will eventually discover a deeper layer, a theory beneath quantum mechanics, a union of gravity and the quantum world, something that finally reveals what space, time, matter, and information actually are. Or perhaps every answer will reveal another layer beneath it, reality, beneath reality, beneath reality. And maybe there is no final floor. So look around again. The screen, the room, your hands, the world outside. Everything feels completely real, and for your experience, it is. But somewhere, beneath perception, beneath atoms, beneath space and time, the universe may be far stranger than anything the human mind has imagined. Perhaps the greatest question is not, are we living in a simulation? Perhaps the greater question is, would we recognize true reality if we saw it? Because maybe humanity's greatest mystery has never been what exists beyond the universe. Maybe it is understanding what the universe